rule, the quotient rule, and the power of a power rule that you would have learned in grade 9. We're also going to review zero exponents, which I believe that most people have probably encountered, but just in case, we'll go over that. And then the new topic is to simplify and evaluate integer exponents, so exponents that are positive and now also negative. Okay, the top part here, product rule, quotient rule, and power of a power rule, these are all things that you would have learned about in grade 9, and they're presented here in such a way that they would be presented if they were in a textbook or if you looked them up online. So no numbers, just letters, and we're going to work from there. So let's try to create an example of the product rule. The product rule states that when the bases are the same, so I could have a base like 5, let's say, and then the exponents, here you have an m and an n, are values, don't have to be the same, so let's do a 4 and a 2. The rule says that I can keep the base the same, so have a b here, so that's a 5, and then add the exponent. So because I'm multiplying, it's a product rule, and because then I'm going to count up all the 5s we have, we can add the exponents. So 4 plus 2 is 6. An example for the quotient rule, it says that when we divide exponents that have the same base, not exponents, sorry, powers that have the same base, we can subtract the exponents. So for example, if we have m to the power of 9 divided by m to the power of 6, I can write a simplified answer as m to the power of 9 minus 6, which is m to the power of 3. Okay, and the last one is the power of a power rule. So when I have a base, and notice here there's only one base, so we can choose x. Some exponent on the inside here, so we'll use 3 as an example, and then a different exponent or another exponent, it doesn't have to be different on the outside, I'll choose 5. The rule says that I keep the base the same, it's x, there's no other base anyways, and then I multiply the two powers. So when I have two exponents side by side, I then multiply them. So 3 times 5 is 15. This next statement here, you may remember learning this, or you might know about this already, is that anytime we have anything raised to the power of 0, it simplifies or the answer is 1. And lastly, the new topic, negative exponents. So what it says in this statement here is that b to the exponent negative n. So let's write that as a number so you can see. So for example, 5 to the exponent negative 2. Oops, sorry. The exponent negative 2. Take my pen back. Okay, negative 2, there we go. Can be rewritten as 1 over the base, 5, but now to the exponent positive n, or positive 2. And lastly, we have these this example here, and there's actually a typo. There needs to be a negative somewhere, otherwise these wouldn't be the integer exponents I'm talking about. So a over b to the power of negative n, and I'll put some numbers in there just so you can work with that instead. So if it was 4 over 7 to the power of negative 3, this can be rewritten as 7 over 4, so flip. Just like here, if you think about it, here we have a 5, and we're writing it now as 1 over 5. The 4 over 7 becomes 7 over 4, and now the exponent can be rewritten as positive. And anytime you're dividing, you'll notice they always have this statement to justify the fact that we can't divide by 0. So these statements here, you don't need to worry about them as long as you remember that whatever's on the bottom, the denominator cannot be 0. We're going to try some examples next. There's some things to remember, and if you want, you can jot these down. I know you have some space underneath the learning goals. Things to remember. You must use order of operations. So if we compare multiplying and dividing to power of a power, we would do the multiplying and dividing first, sorry, we would do the power of a power first because that's an exponent, and then we would do the multiplying and dividing. However, if things are in brackets, we would do brackets first. Okay, so we'll take a look at that, the examples. Anytime we talk about like bases, just think of it the same way as like terms. You can't, there is no rule for combining exponents that don't have the same base, just like you can't add x plus y. Coefficients, so the numbers in front of these variables that we're going to be practicing with, treat them as you normally would. So if it says 3 squared is not 3 times 2. 3 squared is 3 to the power of 2, or 3 times 3, and that actually equals 9. So although the power of a power rule talks about multiplying, don't do that unless you have 2 exponents. And then 2 words just to clarify. If it says simplify, you don't have to find a numerical answer. It might specifically ask you to write as a single power or to write with a positive exponent. So the idea of simplifying is when we have lots of like bases, we want to write it as simple as possible. If you are asked to evaluate, then you find the numerical value or the total, or you calculate something. Okay, on your sheet there are 2 solved examples, so it shows every single step just to help clarify. If you look at this first example, this here is the question. And in the question we have a squared and b cubed all raised to the power of negative 2. So according to the power of a power rule, I want to work with the exponents first, not the multiplication inside because of BEDMAS. Power of a power rule says that this will be, for both of these values, multiplied. So a to the power of 2 times negative 2 and b to the power of 3 times negative 2. We simplify and now we have negative exponents. So we have a negative exponent here, negative exponent here. And remembering the rule, the new rule you learned, that means just flip or create a reciprocal now with positive exponents. So the negative 4 became positive 4. Done. And there we go. And the negative 6 becomes positive 6. And we just flipped it. So the a and the b, the bases, are now denominators instead of numerators. Same idea here with this concept of negative exponents. We want to flip if we can and rewrite using positive exponents. So in this case, the negative 3, if I want to write it as a positive 3, then this numerator and denominator must switch places. We need a reciprocal. Then you can work on the power of a power rule, and that means that this power 3 belongs to everything. So that means it'll be 5 cubed and b cubed, 2 cubed and a cubed. So everything raised to the power of 3. 5 to the power of 3 is 5 times 5 times 5, which is 125. b raised to the power of 3 is b cubed. 2 to the power of 3 is 8. And a to the power of 3 is a cubed. So the trickiest part here is remembering how to flip it right here with the negative exponent, and then everything else can just be raised to the power of 3. Okay, and lastly, you have 5 examples for you to try. This might be a good time to pause the video. I'm just going to give you answers later, and then we can take up solutions and discuss things in class. And as you can see now, you have the final answers shown on the screen. As you can see now, there are final answers shown on the screen.